Hello and welcome to section 4.6. Today we're going to be taking what we used over the last couple sections, proving triangles are congruent, and then showing that their corresponding parts are congruent. You guys had a few proofs. The book likes flowchart proofs. If you guys don't like those, you want to do two-column proofs, that is totally okay. The gray boxes are the statements, and the reasons are underneath the statements. For a lot of these problems, if you're separating the triangles, it's going to make your life much easier. You're going to see how to do these. So if you haven't been separating the triangles, like number 32, that one, a lot of those are much easier where you separate them like that, and I kind of have shown you guys that before, so keep that in mind. Okay, so there's really not a lot of new things in this section. There's one new thing. We're going to prove the triangles are congruent to show that a certain part of the triangles is congruent. It's called CPCTC. And you're going to want to remember this, what it means, corresponding parts of congruent triangles are congruent. So we're going to show the triangles are congruent, and then their corresponding parts are also congruent. Okay, so it says, explain how you can use the given information to prove that the hang glider parts are congruent. So we want to show QT is congruent to ST. So I'm going to show that the two triangles are congruent, and then those two parts will be congruent. Alright, so it's given that angle 1 is congruent to angle 2 and RTQ is congruent to RTS. Okay, so statement, reason, angle 1 is congruent to angle 2, and I'm just going to call this angle 3 and angle 4. Okay, now I know that RT is reflexive, so I'm going to just go ahead and put that down. That's an easy one. And then we're going to be using the theorem that I made up, the linear pair congruency theorem. I know that I'm going to call this one here 5 and this one 6. I know that 1 and 5 are a linear pair and 2 and 6 are a linear pair. And since 1 is congruent to 2, that means 5 has to be congruent to 6. So I'm going to say that angle 1 and angle 5 form a linear pair, as well as angle 2 and angle 6, given from diagram. Then, since 1 and 2 are the congruent, we know that 5 and 6 have to be congruent. So angle 5 is congruent to angle 6. That is my linear pair congruency theorem that I made up and proved earlier this chapter. Okay, so I have these two are the same now. All right, and now the two triangles are congruent by angle, angle, side. And then finally, I can now say that the parts are equal because the triangles are equal or congruent. TQ is congruent to TS. And that is CPCTC. There you go. So that's what this section is all about. All right, so it's use the following method to find the distance across the river from point N to point P. There's a couple questions like this in your homework. I think they're kind of interesting. Place a stake at point K on the near side so that these two segments are perpendicular. Okay, so we're going to place a stake there so that NK is perpendicular to NP. Oh, I got that wrong. NK is perpendicular to NP. So this one would be perpendicular here. Okay, and then find M the midpoint of NK. Okay, so that would make those two equal. And then locate the point on L so that NK is perpendicular to KL. So those two would be perpendicular then, based off of step number 3. Explain how this allows you to find the distance across the river. Well, we know that these two are vertical angles there, and the two triangles are congruent by angle, side, angle. And so since the two triangles are congruent, then all I have to do is walk this measurement here, walk and measure, and this corresponding side is this side here, the distance across the river. So if you walked and measured this distance here, you would be able to then find the distance there. A very far-fetched example. Nobody would actually ever do this, I don't think. But it goes kind of with this section with proving triangles are congruent to show their parts are congruent. So I don't know. I think they're kind of fun. All right, now this is a good one. This is what I call the inception proof. It's proving two triangles are congruent to show two parts are congruent to show two other triangles are congruent. So yeah, this is a fun one. 1 and 2 are the same, 3 and 4 are the same. I want to show that BCE, this guy right here, is congruent to this guy right here. So I have a reflexive side right there and an angle 1 and 2, but I have nothing else. There's no other parts there that are congruent. So what I want to do is I want to show that the larger triangles, this one here, this larger one and this one here are congruent, because then these sides will be congruent and I'll have side, angle, side. So I'm going to show the big ones are congruent first in order to show that those sides CD and CB are the same to show the two triangles are congruent. So this is a great proof. I'm a big fan of it. I'm going to go with this reflexive side right down the middle. CA is congruent to CA. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Given. And then CA is congruent to CA. Reflexive. Which makes triangle CDA congruent to triangle CBA. And that's angle, side, angle. Now, since the two triangles are congruent, now I know that CD has to be the same as CB. So I can mark that here and there. That is CPCTC. And then I already was talking about CE being reflexive before. Okay, so this is the reflexive side. I'm going to use a different color here. I'll use a green. So I should have done this from the get-go. The green marks for the small triangles. So now I have side, angle, side. So now triangle BCE is congruent to triangle DCE by side, angle, side. So this is a really neat proof because you have to show that two triangles are congruent, to show that two parts are congruent, to show that two other triangles are congruent. And that's basically the lesson. There's a lot on here. I marked number 15 as a challenge question because it's just like the one I just did. You have to prove two triangles are congruent to show that two parts are congruent, to show that two triangles are congruent. The other ones, pretty fun questions. A lot of them are good proofs here. Anytime it says plan for a proof, I want you to write a 2-column proof. Okay? And that happens a lot throughout the year. So just that statement goes for every section. If it says write a plan, I want you to prove it. Thank you guys for tuning in to 4.6.